गुड मॉर्निंग। आज हम लोग पढ़ेंगे ड्वेल कन्वर्टर, राइट। अभी तक हम लोग ने वी हैव सीन दैट दिस फुल वेव कन्वर्टर can operate only in two quadrant, right? Means the voltage could be positive or it could be negative, but current is always positive. But as we know that we have to operate DC motor with the help of these rectifiers. So we required four quadrant operation, right? We required four quadrant operation for this. So to obtain four quadrant operation, we required dual converter. Means a converter which can give both positive as well as negative voltage as well as positive as well as negative current, so that we can have all four quadrant operation. Means let me explain here. That means this is our voltage, this is our current. So forward motoring operation, voltage is positive, current is also positive. Then forward braking operation, this is quadrant 1, this is quadrant 2. Means speed has to be reduced, so braking is required. Then we have third quadrant, means reverse motoring operation. Then we have fourth quadrant, that is reverse braking operation, right? This we required for DC motor. To obtain this, our voltage must be positive as well as negative. Current must be positive as well as negative. How we can achieve this, that we will see in today's lecture, which is dual converter. This dual converter is nothing but two converters connected back to back, as it is shown here. Two converters are connected back to back. One converter is this, other converter is this, right? So this converter, the entire setup is called the dual converter. One thing you must remember, that A, or you can say the positive phase voltage is applied here, means in between T1 to T4. So here also you should apply this between T1 to T4, right? Don't change the polarity, otherwise it will not operate properly. So this dual converter, where one rectifier, single phase rectifier, I'll explain both single phase as well as three phase. One rectifier, single phase, is connected here, and other one is connected but in opposite sense. Means the positive is here, whereas the positive of this converter is here, right? So this, the net output voltage would be measured in this direction, right? Output voltage. And of course motor is our DC motor. So this dual converter can operate in non-circulating current mode and circulating current mode. In non-circulating means at a time only one converter is operated. At a time only one converter is operated, means there is no possibility of flowing the current between the converter. Why? Because at a time only one converter is operated, whereas in other mode both converters are operated simultaneously. So when only one converter is operated, that means if we wish to control the motor in forward motoring, what we do, we just operate the converter 1 and it will operate at an angle 90 degree. Means at an angle means 0 to 90, so that output voltage is positive and current is always positive, right? Now when converter 2 is on, and it is operated in rectifying mode. Rectifying means alpha 2 is also between 0 to 90, then you can see here as it is connected in opposite direction, so voltage as well as current both are negative. Voltage as well as current both are negative. VDC is negative as well as IDC. IDC means the output current IU. That is also negative. Clear? Now, we talk about the circulating current mode. In this, what we do, the both converters are operated simultaneously. Means if one converter is operated at an angle alpha 1, other one is operated at angle alpha 2, such that alpha 1 plus alpha 2 is equal to 180 degree. It implies that alpha 2 has to be 180 minus alpha 1. Right? 180 minus alpha 1. So, the converter 1 is operate 0 to 90. Then obviously converter 2 is 180 minus alpha 1, so it has to be operate 90 to 180. That means converter 1 is operated as a rectifier, whereas 2 operate as inverter. Clear? This thing has to be clear. This thing has to be clear. Now, similarly, when converter 1 operates between 90 to 180 degree, then converter 2 has to be operate as rectifier, and its firing angle ranges from 0 to 90, 0 to 90, because it is 180 minus alpha 1. So, this will give you VDC as well IDC, both are negative. Both are negative. Second converter when operate as rectifier, it will give voltage and current both negative. The first converter operate as rectifier, it will give voltage and current both positive, minus, because it is connected in opposite direction. Now let us see the waveform. This is our, let me change the color. Okay, fine. This is our input supply. And converter 1 has to be operate at an angle alpha 1. So let us say this is continuous conduction mode. It is conducting from alpha 2 pi plus alpha 1, and this voltage is coming as V0 1. Now converter 2 has to be operate as at angle alpha 2, which is pi minus alpha 1, which is pi minus alpha 1. So basically this voltage would appear at this voltage is appear at here. This positive, this negative, but we have to, this positive, this negative, but we have to take the reference common. That means this point voltage is minus V02. This point voltage is minus V02. So let us invert the waveform. It would be like this. It would be like this. Now reactor voltage is whatsoever the voltage is at this point V01. Reactor voltage is V01 minus this voltage V02. That means V01 minus V02. V01 minus V02. So the reactor voltage is come out to be V01 and minus of this V02, means this minus this minus this is positive. I mean add up, and in between it is get cancelled. Are you getting me? V01 minus of this, right? So V01 minus this, that means it would be double, and this minus this get cancel out, this waveform get cancel out, huh? This get cancel out, then again this minus this, that means this waveform would come, this waveform would come. Here you can see it is V01 minus V02, right? So that is the voltage generated across the inductor. This is the voltage, this is VR. Let me open the circuit. This is VR. This voltage is VR. It will cause the circulating current. Although the average voltage is same, but instantaneous voltage is different, so it will cause the circulating current, right? Now, if we talk about the mathematics of this, V01 is equal to VDC1 and it is equal to 2 Vm by pi cos of alpha 1. Similarly, VDC2 is 2 Vm upon pi cos of alpha 2. This VDC1 and VDC2 is nothing but this voltage. Let me clarify here as well. If VDC1 and it is equal to VDC2, right? So there should not be any confusion. This voltage is VDC1 and VDC2. Now VDC1 and VDC2 both are same but opposite magnitude. Just put the value of this. You will get cos alpha 1 is equal to minus cos alpha 2, or alpha 2 must be equal to pi minus alpha 1. That we have already stated. It means in the circulating current mode, both converter has to be operated in such a way that alpha 1 plus alpha 2 is equal to 180 degree. One converter operate as a rectifier, so other converter operate as an inverter, right? And vice versa. Now, if we talk about the this advantage of circulating current mode, this circulating current mode, it maintains the continuous conduction of both the converter, right, over the entire speed range. So independent of the load, whether it is a light load condition or it is a high load condition, the load is the current is continuous, so the motion is smooth. That is the one advantage of this. Now, other advantage is as one converter is always operated as rectifier and the other operate as inverter. So power flow in either direction, means from source to load or from load to source, is possible because you have both the choice all throughout the time. That means you have one converter operated as a rectifier, other converter operated as an inverter. So in both direction power can be flow, right? So other thing is, as both converters are operated in continuous conduction mode, so response is very fast, means dynamic response is very fast. Means if you want to increase the speed, means operate as a motoring mode, yes, you can do. You just reduce the firing angle and get the voltage high, and it will increase the speed. Similarly, if you want to do the braking operation, and then also you can do this, right? Means change over from first quadrant to second, or second to third, or third to fourth is fast. That is why the dynamic response is fast in case of dual converter. Clear? Dual converter and the circulating current mode, right? Not in non-circulating current mode, because there the only two converters are operated. Converter 1, which can operate as first and fourth quadrant, and converter 2, which can operate in second and third quadrant. But in circulating current mode, both converters are operated, so switch over from one quadrant to another is quite fast, right? Now, if we talk about the disadvantage of this circulating current mode, see, there is always some circulating current between the two converter, right? So there is losses, that is losses occur in that, and that reduce the efficiency of the converter, right? Other problem, even if load current falls to zero, that means you don't require any torque, right? Motor is running at its own speed, right? You don't require any torque. Even if there is flow of current between the converters, there must be some circulating current, right? So that even though you put the reactor that limit the peak circulating current to a safe level, but minimum current must be, there is always flow of current. That is the another disadvantage. Another thing, that thyristor rating must be quite high, because it has to carry the load current as well as the circulating current. So the thyristor which are used for the dual converter in circulating current mode, that is little bit higher rating, right? And here you can see that all four quadrant are possible. In this case, you can go from forward motoring to forward braking, then from forward braking to reverse motoring, then from reverse motoring to reverse braking. And if it is non-circulating mode of conduction, then what you have to do? Well, the converter 1 can operate in first and fourth. Means if you require forward motoring or reverse braking, then you have to operate the converter 1 at 90 degree, between 0 to 90 for forward motoring, and for reverse braking you have to operate converter 1 more than 90 degree. Similarly, for forward braking and reverse motoring, only converter 2 need to be operated for non-circulating current mode, and that for reverse motoring, alpha 2 is less than 90, means in between 0 to 90, whereas for reverse forward braking it has to be operated greater than 90. So this type of operation can be achieved, means all four quadrant operation can be achieved in both type of operation, whether it is a circulating current mode or whether it is a non-circulating current mode, right? Now if we see the three-phase dual converter. Three-phase dual converter is also similar to single-phase dual converter. The only difference is, in the place of single phase you require two three-phase converter, and they have to connect it back to back, and they have to be connected back to back. This is 135, this is 462. It is connected like this, so it will produce voltage like this, it will produce voltage like this, and it will produce voltage like this. Now let us see the waveform. Let us see the waveform. See, these are our waveform. These are our waveform. This is your VCB. This is your VAB. This is your VAC. This is your VBC. This is your VBA. This is your VCA. This is your VCB. Now it is repeating. Let us consider the case when alpha 1 is equal to 60 degree. As you know, the 0 degree is here. For VAB, that means 6 and 1 thyristors are conducting. We have already discussed so many times. If you wish to refer, you can refer all those lectures where I have explained the full wave rectifier, right? So let me increase the size. Now, this is 60 degrees. 0 is here. Now, alpha 1 is 60 degrees. So, the waveform would start to conduct at this point, and for how much duration it has to be conducted? For 60 degrees. So, VAB will come up to this. converter 1 voltage. This is converter 1 voltage, right? Now, after this, alpha 2 is how much? It is 180 minus 60, that means 120 degree. So 0 is here and 120 is here, and for the 60 degree it needs to be operated. So this is for converter 2. Now you can draw the voltage for all. You can draw the voltage for all. It would be like this. These lower portion is converted to voltage, this lower portion is converted to, and this upper portion is converter 1 voltage for the firing angle of 60 degree. As we did in the single phase, we have to draw the minus V02. We have to draw the minus V02. So what we did, we simply take the reflection of this. So it would be like this. It would be like this. It is the reflection of this. Right? So this voltage is basically converted to voltage with minus signs. Means we are putting this. We are measuring in this. So that reference point is common. Now if we want to know the voltage between this, it has come out to be V01 minus V02. V01 minus V02, that means V01 plus V02. Now we have to add these two. So this plus this, it has come out to be this. This plus this, it has to be this. V01 minus V02. V01 minus V02. Right? That we have to do. So it has come out to be this. This is the reactor voltage. This is the reactor voltage. Right? V01 minus V02. That means V01 plus V02. Clear? There should not be any confusion. There should not be any confusion. Just this voltage is V01 minus V02. Right? So it is come out to be this. It is come out to be this. Clear? Now, what we have to do? What we have to do? Just the graph is displayed. Just give me a second. Just give me a second. Now it is okay. Now it is okay. Clear? So the output voltage is V01 plus V02 by 2, the average of the average between this point. Average between this point. It is come out to be this. If we talk about the circulating current, the circulating current is like this. And the converter 1 current is, as the alpha 1 is 60 degree, means we are operating as a motoring mode, right? So I1 is greater than I2, and this value is I0, right? So when you subtract this, I1 minus I2 is the load current, that is come out to be I0. That is come out to be I0. Clear? So this way we can achieve the all 4 quadrant operation of dual converter. So with this lecture, it took around 8 to 10 lecture to cover the entire rectifier. We have studied the single phase, we have studied the 3 phase, we have studied the semi converter, we have seen the effect of source impedance, we have seen the effect of freewheeling diode, We have seen the various type of conduction, continuous, critical continuous, discontinuous conduction. Even if you have any type of doubt, I suggest kindly mention either on the comment box of YouTube channel in the lecture itself so that I'll explain, or you can direct message to me. My WhatsApp number is 9839242490. So with this, I end this second unit. In coming lecture, we will start the chopper. Right? Okay. Thank you.